Yeah, please let me know whether I am audible or not. Okay, we are going to solve manam previous year questions, network analysis previous year questions, అన్ని questions solve చేస్తాము AP AEE paper వి, right? So ప్రతి question లో we are going to learn concept also. It is not just solving the question, we are going to learn concept also from the question. That is the main motto of this session. Okay, main motto of this session, right? So what is the very first question? First question ఏంటంటే a star circuit and its equivalent delta are shown. Okay, the resistance between the terminals A and B in the star circuit with C open. Star circuit, he is saying, with C open is 10 ohms. Okay, right? Between A and B terminals with C open means C is left open. Right, I'm doing it. Observe, this is R, this is also R, this is a terminal A, this is a terminal B. Yes, this is a terminal B. C left open means it is floating. It is floating. C open chesasamu, it is floating, right? Somebody else already answered. Jay Sai already answered. Okay, we'll solve it in detail, right? Now this is RAB. Let me tell you, which is equal to 2R. That is equal to how much given by him? That is equal to given by him as 10 ohms, I guess. Yes, how much it is mentioned? That is equal to 10 ohms. Then R value is 5 ohms. R value is 5 ohms. The resistance between terminals B and C, A and B with C open in delta will be. He's asking C he wanted to open, but in delta, if you open C, something else is going to happen. Okay, in delta, if you open C, something else is going to happen. That is, this is okay, and he's asking us to convert that star to delta. This will be 3R, 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 right? Now this is A, this is B. Between A and B we have to observe C open, nothing will happen. Now these two are going to be in series. Now that will be 6R in parallel with 3R. 6 in parallel with 3 will be 2, I guess. 6 into 3 by 9, 3 3, yes, that is going to be 2R. 2R, 2 into R is how much? 5. That is equal to 10 ohms. That's all. Very good, Jai Sai. Very good. So that is how much? 10 ohms. You see, very simple it is. You see, very simple it is, right? Yes or not? Yes. Observe it carefully, please. Very simple question. If any kind of questions you have, you can answer in the chat box. Okay, in the chat box you can answer, right? Simple question. Okay, star, when you convert into delta, the resistance will be increased by 3 times. From delta to star, it will be decreased by 3 times. Okay, and the main fundamental between star to delta, delta to star conversion is power should remain same. Suppose if I ask, if a star connected network of RRR is consuming 100 watts, if the same network is converted into delta, I am repeating the statement, it is converted to delta. Okay, means we are not reconnecting. Star to delta conversion we are doing. How much that delta connected network will absorb power with same source terminals? Answer me, please. I repeat the question. We have a star connected network with RRR. It is connected across some voltage source terminals. It is consuming power of 100 watts. Now the same network we are converting into delta with the same source terminals. How much power it is going to take? Same 100 watts. Star to delta, delta to star is a conversion. Okay, we are not reconnecting it. Don't misunderstand. People will misunderstand between conversion and reconnection. See, star to delta conversion, see, this is very crucial point. Why? Because people, one time in GATE examination, 2013 GATE paper, IIT Bombay conducted, this kind of question was given. You can refer that paper if you want. Good question. It was R. This is exactly same as the top. This is, yes, this is 3R. Means, what does it mean by equal? Means if it is consuming a power of some 100 watts, this also consumes same power of 100 watts. This is conversion, star to delta, delta to star. Then what is reconnection, sir? Let me add a white page here and then I'll discuss what is reconversion. Reconnection, sorry, not reconversion, reconnection. Means I have a star connected RRR. Now This is not equal to, this is not equal to, yes, this is not equal to this one. Okay, this and this both are not same. This is a reconnection, means we are dismantling those resistances, assembling this way. Okay, that and this both are not same, both are not equal, not equivalent in fact, right? That's a good learning. Next question, an EMF of 1.5 kV is induced in a coil. Coil means inductor, okay, where E is equal to L di by dt. How much it is induced? 1.5 kV with a current, when a current of 4 amperes collapses uniformly to 0 in 8 milliseconds. L dt is 8 milliseconds, right? Di 4 to 0 means final current is 0, initial current is 4, I2 minus I1, right? I2 minus I1 by T2 minus T1. Then the inductance of the coil is very simple, ma. Okay, L is equal to 1.5 into 10 cube into 8 milli, 8 into 10 to the power of minus 3 divided by 4, 4 2s to 1.5, 3 times this gone, that is simply 3 Henry. Answer is going to be how much? 3 Henry. Answer is 3 Henry. Simple question. See, the class is not just for sitting and listening. You can participate in the discussion. Okay, you can solve in parallel with me. In fact, you can solve more fastly than me because I am explaining. You need not to explain to anyone. Just you solve it. If you have any questions or any concept doubt, you can ask me directly over here. Yes, I repeat, you can directly ask me over here, right? Next, this question is related to maximum power transfer theorem. The maximum power that can be, yes, I think now it is visible clearly. Yes, the maximum power that can be transferred to RL inverts in the circuit shown is asking how much maximum power can be transferred to this RL. What is the condition? RL must be equal to R Thevenin. Sometimes it is also called as R source. If it is a simple network, that is equal to RS. If it is complex network, we have to find its Thevenin's equivalent resistance. How to find Thevenin's equivalent resistance? You remove this and stand here and look into those terminals. Yes. See, we have targeted resistance, load resistance, remove it. Go and stand there in the place of load resistance. From there you see, right, towards the circuit. And when you are finding Thevenin's equivalent resistance, we have to open circuit the current sources and short circuit the voltage sources. Sir, if there are dependent sources, then story is different. If there are dependent sources, we have to do VOC by ISC. Okay, open circuit voltage by short circuit current is going to give us Thevenin's equivalent resistance. Actually, we have 3 cases in Thevenin's equivalent resistance finding. All are independent sources, just open circuit current sources, short circuit voltage sources. That is pretty simple. If there are dependent sources, VOC by ISC, right? Sir, if there are no source at all, right? That is, if there are no sources at all, that directly that can be found, right? So there only RTH will be existing, VOC does not exist, VOC or VThevenin does not exist. Now come here, stand here and see how much that is 8 ohms. Why? Current source should be open circuited. Current source should be open circuited. Now he's asking maximum power that can be transferred. So P max is equal to V Thevenin whole square by 4 times of RTH, which is equal to RL, which is equal to RL. Sir, here V Thevenin is not there. How can I solve? Now convert this voltage current source in parallel with resistance as voltage source in series with resistance. Apply, what is that? Source transformation theorem. Yes, source transformation is a theorem. Convert it. What do you get? You get 8 ohms, yes, and 40 volts plus minus. This is 40 volts. This is the converted circuit. This is RL, which is variable. Now from here, if you see V Thevenin, which is equal to VOC, is equal to 40 volts. Because when you are finding Thevenin's equivalent voltage, the targeted terminals must be open circuited. We open it, then no current is flowing. 40 volts it is placed. Now P max is equal to 40 into 40 square divided by 4, sorry, by 2 right to square again. Yeah, it is redundancy. 4 into how much it is? 8. So 4 tens, yes, 5, how much it is? 50 watts. Answer is how much? 50 watts. He's asking the question itself in terms of watts, therefore In the options, he did not mention watts as units. It's okay. It's okay, right? Yeah, somebody solved PVB2. Yes, the username PVB2 already solved it. It is 50 watts. Simple question. Now, this is a good question. This is a good question. Maybe I feel some data is missing in this. No, let's see. If data is missing, I'll let you know. Otherwise, it's a pretty good question. I am giving you a challenge for all of you to solve this question. If you ask me to wait, I'll wait for some 1 minute. It's a good question. Try it, all of you. Try it. Those who are there in the class, please try to solve this question on your own. It's pretty good question. Okay. It is a good question. Is asking, in the circuit shown, the frequency of the sinusoidal source is about. Is asking about the frequency. Now, means something, if you see some very good inferences can be made from this circuit. Means a lot of learning is possible from this circuit. Sir, sorry for asking, sir. Is Shivani our person? I don't know, ma. Who is Shivani? I don't know, please. I don't know. Right? Any question you have, directly ask me. Okay. Yeah. Now, if you see, this is the voltage. What is the applied voltage? Voltage applied is 100 at an angle of 30 degrees. Now, the current, fortunately or unfortunately, the current that is flowing in the circuit is 10 at an angle of 30. Observe the angles. If you see these two angles, angle is not changing. In which case, angle will not change? In case of resistance. In case of resistance, angle will not change. Sir, but the circuit is having inductance and capacitance. How you can say resistive circuit, sir? This is under resonance. Yes, resonance circuit. Sir, how do you know it is under resonance? These two are equal. This is J10. Now, this is going to be minus J10. This is going to be minus J10. Right? XC is given by him 10. XL not given by him, but you can take it as 10 magnitude. Sir, how? Circuit is purely resistive. Somebody given the answer. Very good, PVB2. Okay. Sai Vamsi Ram. Answer given by him as D. Yes, it is D. It is D. I'll solve it. It is under resonance. Sir, how do you know? It is having RLC, series RLC, but current is exactly in phase with the voltage, in which case this is voltage, current is also, and this is XC, suppose, sorry, this is VC, voltage across, sorry, this is VL and this is VC, both are exactly equal and opposite, that will get cancelled, right? Now, XC is 10, XL is also 10, right? XC is 10, XL is also 10, right? Now, what is XC? 1 by omega C. What is XL? Omega L, right? Omega L is equal to 10, but that fellow L is given as how much? 0.1. So that is 10. So omega is equal to how much, man? 100. Omega is 2 pi F, that is equal to 100. So F is equal to 50 divided by pi. So 50 divided by almost 3 point something. So how much it is going to be? It is not 100. It is not 25. It is not 50. Option is D. See, I suggest you don't waste your valuable time in doing these bloody calculations. The reason is 100 means not possible. 25 3s are 75, which is numerator 75 is not there. 50 means 150. It should be numerator should be 150 in this expression. So 16 heads it is, right? Next question. So the graph shown in figure represents RLC constant values. You see, R resistance is constant, which is independent of frequency. If you plot resistance value with respect to frequency, ideally it is going to be constant, some value, suppose some 10 ohms like that. If you take XL, inductive reactance, that is 2 pi FL. If F increases, XL is going to increase linearly. F is equal to 0. F is equal to 0. Yes, reactance is also 0. XL is also 0, inductive reactance. Now, XC is 1 by 2 pi FC. F is equal to 0, then XC is infinity. If F is tending towards infinity, so this is tending towards 0, right? Means this is F, this is XC. When it is 0, 0, from there onwards, it is keep on decreasing. It is XC versus frequency. It is what? XC versus frequency. Option is B for Bombay. Right? Good. Yes, it's a pretty simple question. All these are previously asked questions. These are not my own questions, right? So which of the following two-port network, two-port parameters is dimensionally different from others? Okay. Now, Z11 is ohms, na? Z parameters are ohms. Yes, Z parameters are ohms. H11 is also ohms. What is the parameter B? But in ABCD parameters, Vs is equal to AVR plus BIR. Is is equal to what? CVR plus DIR. Right? Parameter B. So Vs is equal to, if I'm making receiving end as a short circuit, Vs is equal to BIR. When you get this, when VR is equal to 0, that is receiving and short circuit. B is equal to what? Vs by IR. This is also ohms. Sir, what about H parameters? H parameters. Let's understand what is H parameters. In H parameters, we know output voltage. See, V2 is known. Input current is also known for us. Unknown are what? V1 and I2 are unknown, right? Unknown in terms of yes, known. Unknown in terms of known. Writing is so V1 I don't know. In terms of V2, yes, these are the known quantities. These are the known quantities, right? V2 I1, yes, I1 V2, right? Now V1 is equal to, yes, did I take it in reverse way? Input current we know, output voltage we know. These are the known quantities. Known. Unknown are V1 is equal to, yes, H11, yes, H11 I1 plus H12 V2. Perfect. Now, if you make receiving and open circuit, V2 is equal to 0, or 4 to 2 open circuit, now H11 is equal to V1 by I1. This is also ohms. That's what I wrote. That is also ohms, right? Now, what is H22, sir? I2 is equal to what we get? I2 is equal to H21 I1, means H21 is dimensionless, plus H22 V2. So H22 will be I2 by V2, which is a mhos or Siemens, right? So this is our answer. All these three are having ohms, but the last option D is not having ohms. It is having the units of mhos, right? Try this question, all of you. Please try this good question. Yes, all of you. I am giving you what. See, take this session to test yourself and to ask as many questions as possible to me, and try to learn the concept in more simple, short, and smart way, rather going conventional way. Why? Because we are left with 55 days of time for your examination. Then all these are, companies are conducting single examination. Okay, so don't miss this opportunity. This is, I name this one as lifetime opportunity. Why? Because in lifetime only once we get this opportunity, not every time. In the circuit shown in figure, the switch is in position 1 for a long time. Means, so if anywhere you see something is some switch is there in some position for a long time, means that attained steady state. If he says, I repeat, if you see a statement like switch is there in a particular position for long time, that means circuit attained steady state. Sir, what happens if it attains steady state? If a circuit attains steady state, it means to say that in that if there are capacitors, those will behave as open circuit, inductors, those will behave as short circuit, right? Capacitors will behave as open circuit, inductors will behave as short circuits, right? So who is this B 3 times why to type men, right? Mashallah. Why 3 times B? One time is enough. Okay. Now it is in steady state. First of all, means before for all t less than or equal to 0. Yes, not less than or equal to, less than only. Less than 0. Exactly t is equal to 0. That is the verge of operation. We are unable to comment anything about it. So this is 50 volts. How much this is? This is 10 ohms. The current is 50 divided by 10 is 5 amperes. How much it is? Current is 5 amperes. This is IL of 0 minus, which is equal to IL of 0, which is equal to IL of 0 plus. Sir, why, sir? Inductor does not allow sudden change in its current. Now that switch position is changed to here, no more switch here, right? Now this current cannot change its direction immediately. Current cannot change its value suddenly. First of all, forget about direction. So how much is the initial current? 5 amperes. This is RL network. RL network, only RL, no source, no source. You remember, either it is RL network or RC network without source, the things keep declining, means decreases exponentially. I repeat, see, this is the most simple fundamental to remember. If you find RL network or RC network, if it is not having source, then voltage across capacitor in RC circuit decreases exponentially. Why? No source. Capacitor is the one which is feeding. For how much time it can feed? For some time only. It means it is decreasing. That mathematically, if you do the derivation, you will get it as exponentially decreasing. You will get it as exponentially decreasing, right? So the point here is RL network with no source, current decreases exponentially from initial value. So IL of t, current through inductor, which is same as that of current through the switch, which is same as that of current through the resistance. Why? Because switch and resistance and that inductance all three are in series, right? IL of t is equal to initial current. How much it is? 5 into e power minus t by tau, where tau is equal to L by R, L equivalent by R equivalent. Sir, how to find L equivalent, R equivalent? Here it is okay, only 1 L, 1 R. But if the circuit is big, if the circuit is complex, then you have to divide that one into two parts. Two parts division means don't think in whatever the way you wanted to divide it. No, all resistances one side, all inductance or capacitance other side. Now find R, L equivalent and R equivalent, right? Means L equivalent means what? Series parallel combinations. R equivalent, same series parallel combination. What is L equivalent here? 0.2. How much is R equivalent here? 10. How much it is? 0.02. So IL of t is equal to 5 into e power minus t divided by 0.02. 1 by 0.02 is how much? 50. E power minus 50t, right? 5 into e power minus 50t. Yes, sir. Option it is C. Okay, option it is C. B is wrong. B is wrong. Option is C, right? Gautam and who is this? Another person, some guru, some Nishita. Yeah, option is C. Yeah, fine. So that is pretty simple question, right? But the only thing what we have to understand here is learning. That is, inductor does not allow sudden change in its current. Capacitor does not allow sudden change in its voltage. Then if something is mentioned like switch is placed in position 1 for a long time, means anywhere if it is placed for a long time, then the circuit reaches to steady state. Steady state means inductor behaves as short circuit, capacitor behaves as open circuit. Means here something very important, if you are willing to learn some small thing, small detail I wanted to mention here. So t is equal to 0 if you take it as starting or initially, whatever it is. Inductor will behave as open circuit, capacitor will behave as short circuit. Sir, here also I'm getting confused. Sir, how to remember this one? I'll tell you. So inductor does not allow sudden change in its current. Why, sir? What is inductor energy formula? Half L I square. So inductor energy is directly proportional to current, inductor current. Now in this practical world, never any energy change suddenly. So energy cannot change suddenly, current also cannot change. Current is not allowed to change suddenly. Means if previous current is 0, present current also will be 0, therefore open circuit. For capacitor, what is the energy formula? Half C Vc square. So EC is directly proportional to Vc square. This cannot change suddenly, therefore this cannot change suddenly. Voltage cannot change suddenly. If the previous voltage is 0, present voltage is also obviously 0. So capacitor will behave as voltage is 0, means short circuit. Now this is exactly reverse at t is equal to infinity. At t is equal to infinity, inductor behaves as short circuit, capacitor behaves as open circuit. For this there is some other different explanation conceptually, but I don't want to take it. But or if you wanted me to take, I'll take it in a simple way. So inductor V is equal to L di by dt. Finally, inductor reaches to steady state, means fully it stores. Like suppose if you take some mug, you are pouring water in it. Up to some extent it will store. After that, its storage is full. Means the change of water in the mug is 0. Here also, inductor fully stored, inductor stores energy in the form of magnetic field, capacitor stores energy in the form of electric field. So that's why once it fully stores, no further change in current. Therefore, voltage across the inductor is zero at steady state. At steady state. Now, in the same way, current through capacitor I is equal to C dVc by dt. Once capacitor stores fully, see, capacitor stores energy in the form of electric field means in terms of voltage, right? So there is no further, means how much further, how much more time you connect it, but it is not going to be useful because it is already fully stored. Further change in voltage is zero. This is zero. So IC is going to be zero. IC is zero means it is going to be open circuit at steady state. At steady state, right? So these are the few fundamentals logically how to remember without any confusion. Just I am giving over here, right? Let's go for the next question. I hope this question is very small. It is looking. That's why I'm redrawing it. Let me draw. That's fine. So this current is I of t, right? This is 1 Henry. That's fine. This is 1 ohm. That's fine. This is 1. It is not C, 1F it is. What is C? Type is the typo. Okay. So he's asking current by voltage transfer function. Okay. Transfer function, Laplace transform, I by V. In fact, it is admittance. Okay, apply Laplace, that's all. Apply Laplace. This will become V of S. This fellow will become I of S. This is LS. L is 1. This is 1 only. This is 1 by CS. This is 1 by S. Now, current is equal to Ohm's law, voltage divided by total impedance. Now, this is in ohms. This is in ohms. This is the so specialty about S domain. Everything will be converted into ohms, inductance and not everything. See, don't take my words in different way. R, L, C, all three will become impedances in S domain. In time domain, L is L only with the units of Henry. C is C only with the units of farads. But if you convert into S domain, 1 by CS, its units are ohms. V of S by R, how much? 1. LS is S. 1 by CS is 1 by S. So I of S by V of S is equal to S by S square plus S plus 1. That's all. This is pretty simple. S by S square plus S plus 1. Option is A. Option is A. So none of you answer, man. Why? Yes, yes. See, the spirit is reducing in you. Okay. Answer is A. Damn simple question. See, if you are good at simple Laplace transform and bloody Ohm's law, you got it, right? You got it. Yeah. Now, let's try this question. All of you try it. I'm giving you 1 minute of time. All of you try it. I'm giving 1 minute of time. What is the question? A balanced delta connected load draws 20 kilowatt at a power factor of 0.8 leading. That's okay. He given P, he given cos phi. If the line voltage is 800 volts RMS, the magnitude of the RMS value of line current. Damn easy question. Only one liner it is. That question is one liner. I'm expecting an answer from all of you. There are around 12 guys in this class. Okay, those who are attending, please, I'm expecting answer from all of you for that simple question. Yes, I'm giving you 1 minute of time. Do it. Yes. Some people answered it. Okay. Who is that? Nishita. Yes. Answered. Option is A. Okay. Let's see. Let's see. I don't know how to solve. Given P. P is equal to delta connected means root 3 VL IL cos phi. That's all. Whether it is leading or lagging magnitude. That fellow is asking about bloody magnitude. So that is very simple. 20 kilowatts. 20 into 10Q is equal to root 3. What is the voltage? Line voltage and phase voltage both are same in delta. That is a crucial point we have to remember, understand, and apply over here. Right? In star connection, line voltage is root 3 times of phase voltage, but in delta, line and phase both are same. Current in delta is root 3 times line current is root 3 times when compared to phase current. Right? So How much it is? 800 into IL. This is line current. Cos phi is power factor. How much it is? 0.8, right? So 0.8. Now he's asking line current only directly, not even phase current. This is a question. I hate this kind of simple questions. Okay, 1000 divided by root 3 into 800 into 0.8. Solve it. 20 into, so 2 into 10 to the power of 4. 2 into 10 to the power of 4 divided by root 3 into this is 8 into this is, I'll make it 8, remove 1 0, 8 into 80, 640, 640, 0, this will be cube, right? So 2 32s, so 10 cube, 1000 divided by 1.732 into 32. You must be good at calculation. I am not going to do it. I am not doing this bloody calculation. Just from the options, you can justify whether your answer is correct or not. So 32 1.7 times means 32 into 1.7, almost 32 plus how much it is? 21 plus 1.4. Okay, how much it is? 2 3 4. How much it is? 3 plus 2 5, 54.4. Correct me if I'm wrong. Okay, 1000 divided by 54.4 something. So 50 is 1000 means around 20, right? It should be less than 20. It should be less than 20. But I can say 25 is purely eliminated. I'm not that good in calculations like you, right? It is not going to be 18 also, in fact, because 18 is very near to 20, right? 20 it is not possible. Why? Because 4.4 extra is there. Either option maybe C or D. Anyhow, you have to calculate it, it seems. Okay. Yeah, people are saying, yeah. Is that? I committed mistake. You're getting 18.4, this one calculation. Please respond in the chat box. Please respond in the chat box. Is that? So it means I committed some calculation mistake. Okay, process is this only, just you do this calculation. I hate calculations. Okay. Now this next question is, see, people may feel difficulty in doing this question. That is damn easy question. I am expecting answer within 30 seconds from this question. If you are taking more than 30 seconds for this question, check your fundamentals, whether you are good at fundamentals or not. Okay. The average power delivered to an impedance 4 minus j3 ohms by a current of I of t is equal to pi cos 100 pi t plus 100 degrees amperes is. Just is asking power. Power is equal to V square by R. That V should be RMS value, or I square into R. That I should be RMS value, right? Either V RMS square by R or I RMS square into R. Direct question. Okay. Yes, let me do. So this is I of t, that fellow given as 5 cos 100 pi t plus 100 degrees. So if you compare this one with Im cos of omega t plus theta, so Im maximum value is 5. What is IRMS? IRMS is Im by root 2, 5 divided by root 2. Now power, average power P is equal to IRMS square, 5 by root 2 whole square into resistance is 4. How much it is? 25 by 2 into 4. This is 2 times 50 watts. Answer is option A. That's all. Good. Nishita, good. Option is A. Only few people are answering. Others, they are quite, I don't know why, feeling feared or feeling shy. Chapandi, any question you have in your mind, you can post it in the chat box. I'll be looking into it and I'll be answering, right? Yeah. Just now I told you how to find time constant. Now what is the time constant of an RC network? For an RC network, tau is equal to R equivalent into C equivalent. Okay, do this and let me know the value. Okay, I told you how to find R equivalent and C equivalent. 1 minute is the time I'm giving. Do it. All of you should do. Answer please. This is damn simple question, man. Answer R equivalent into C equivalent. See, as I told you, divide your network into two parts. Okay, so C equivalent I want 1 farad, 1 farad parallel capacitance will be added to 2 in series with 1. That will be parallel. It is same as that of parallel combination of resistances. 2 into 1 by 2 plus 1 is 3. That is 2 by 3. What is R equivalent? R equivalent, just you stand here. Voltage current source can be open circuited, voltage source can be short circuited. 3 plus 3 will be 6. Now tau is equal to 2 by 3 into 6. 3 twos, 2 twos are 4 seconds. Answer is what? 4 seconds. Option is B. B for Bombay. Right? Nishita, good. And who is another person? Mr. Tejas, good. Option is B. Only 2 guys are responding. Other guys, I don't know what happened. Now answer this question. Okay, answer this question, please. Try it. All of you try to answer that question. What is saying in the circuit shown in the figure is okay. The circuit shown in the figure is in steady state. That's fine. Accepted. Okay, steady state without closing the switch means before t is equal to 0, switch was open. Now at t is equal to 0, that fellow is closing the switch out of his own interest. We are least bothered for that. Okay, that is his interest. When the switch is closed at t is equal to 0, assuming that the inductance is ideal, that's fine, accepted. The current through the inductor at t is equal to 0 plus is equal to nonsense. At 0 plus sudden change, see, practically 0 minus 0 plus and 0, all three are same. Sudden change of current is not possible. Therefore, how much it was previously, the same current is going to maintain. At steady state, this fellow is going to act as short circuit. You all know that. I told you already. Then 10 by 10 is 1 ampere. That 1 amperes at t is equal to 0 minus t is equal to 0 plus 0. The current through inductor is 1 ampere only. Sudden change of current is not possible. Option B, B for Bombay. Right? Good. Nichita, good. Tejas, good. And who is this? Gautam 2004. Okay. Good, good, good. Directly, it is option B. Next. Try to answer this question, please, all of you. Try to answer this question. What is saying? If each branch of delta circuit has impedance of root 3Z, that's fine, accepted. Then each branch of equivalent star circuit, see, delta to star to delta impedance will increase by 3 times. Delta to star, it will decrease by 3 times. Nah? So he's saying in delta it is root 3Z. In star, it will be by 3. Z by root 3, that's all. This is option D, D for Delhi. Good, Mr. Gautam. That speed is needed. That speed. Okay. Read the question properly, answer it simply. That speed is needed, definitely. Okay. Yes. Any question any one of you having here? Any question any one of you having here? Right? Good. Good, Nishita. Next question. This is, I don't know how they are selecting for AW post by giving this kind of simple questions. Really, this is ridiculous. See, to select a good candidate, question should be good, but they are giving, like I can say, comedy questions. That fellow given the Z matrix of two-port network is given by Z is equal to 4, 3, 3, 6. The element Y22 of the corresponding Y matrix of the same network. See, Y simply is inverse of Z, 2 by 2 matrix inverse. That's all he's asking. Now 1 by AD minus VC, how much it is? 24 minus 9. So this place can be exchanged. Here sign can be negative, right? That's all over. He's asking about Y22. 4 divided by how much it is? 24 minus 9. 20 minus 9 is how much? 11. 11 plus 4 is how much? 15. I'm weak in calculations. Okay, I left the calculation part when I completed my master's. After that, I got never any opportunity to do the calculation because I used to do with the calculator. Yes, 4 by 15. How much it is 4 by 15? If you want, that can be, actually it should be 4 fourths. If it is 16, 3 point something you will get. 1 by 3 point something you get. 1 by 3 point something means more than 3 it is. It should be less than 0.3. It should be less than 0.3. This is not correct. This is not correct. This is also not correct. But minus is there. Option is A. See, I go simply with common sense than with calculation. I trust my common sense than calculations. Okay. Correct me if I'm wrong in the calculation part. Okay. Come on. See, at this kind of questions, you can save your valuable time, lot of time. People are asking, sir, time is not enough, then what to do? Here, 30 seconds are enough if you are good at the concept. Now, whenever a big question is given, there you can utilize this time, what you got saved here, right? Good. Try this question. This is just one equation. Only one equation, not more than that. Try it. 1 minute of time I'm giving. Answer, please. See, it is a series circuit. Current is same. This 1 ampere, the same 1 ampere will go, same 1 ampere will go. If it is 1 ampere is going plus minus, this is 2 volts. He's asking for that VAB. Write KVL. Sir, where to start, where to end? Wherever you wanted to start, you started, but end there only. Because KVL means Kirchhoff's voltage law, that is applicable only in a closed path. Only in a closed path. Sorry, if closed path is not there, you imagine closed path is there and give some dimension like this plus minus VAB. This is VAB. I'm writing minus VAB. I started here. Never you get confused, sir. That fellow told to move this way only. Nothing. Who is he to us to told to move that way only? We can move in whatever the direction if you want, right? Minus VAB plus 2 plus 5 is equal to 0. So VAB is equal to 7 volts. But answer is not there. I don't know. Maybe typo. Minus VAB plus 2 plus 5. Yeah, you can move this way also. No problem. Minus 5 minus 2 plus VAB is equal to 0. VAB is equal to 7 volts. How people got the answer? As the question is, yeah, 7 it is. Yes. Tejas, you typed it as B. To this question only or previous question? Nishita, you also. Yes. Jaisai, it is 7. It is 7. As per the question, maybe, when typing was done, it may be typed in wrong way, like instead of 1, it may be typed as 5. But as per the question, it should be 7. Yes. Come on, man. Tejas and Nishita given the answer as B, B, B. Now, what was the answer for the previous question? Is it B? Yeah. No, that is wrong, ma. Nishita and who is this? Tejas. Both of you, please check yourself. The answer given by you is B. And this is actually previous engineering service examination question. Maybe you mugged the answer. I don't know whether you mugged or you did it. That is direct answer. And tell me if you have any confusion in writing KVL. I will explain you by taking some 10 minutes of time. I don't have any issue to explain KVL. Please, I'm waiting. I'm waiting. If you decide where you committed mistake, Nishita, Tejas, please, both of you, where you committed mistake, don't hesitate. See, you are aiming to become assistant executive engineer. It's one of the prestigious posts in Andhra Pradesh. Not only in Andhra Pradesh, in entire India. These days, the craze for government job is very high. Okay, as private sector is corporate sector, I should not say private sector, corporate sector is under turbulences, lot of turbulences. So that's why the craze for government job, even for a peon job also, it is very high. But you are aiming for a prestigious job, you should not hesitate to ask or to speak or to type in the chat box. Okay, that should remove first. None of you doing. Okay, leave it. Let's go for the next question. This question is clearly visible. Visibility of the question. In the figure, the admittance values of the elements in Siemens are YR, okay, YL, okay, YC, okay. What is the value of I as a phasor when the voltage E across the element is 10 at an angle of 0? Is asking current I, okay. So this voltage, we know this voltage parallel na voltage is same. Then what is this current? The current is equal to I is E by R, but E into YR. How much it is? 10 at an angle of 0 into 0.5 plus 10 at an angle of 0 into, yes, what is that inductance related to? Minus J 1.5 plus 10 at an angle of 0 into J 0.3. How much it is? 2 at an angle of 0 plus, sorry, not plus, minus, no? Minus J means 90. Plus J means plus 90, minus J means minus 90. How much it is? 15 plus, how much it is? J 3. Now 2 means 2 at an angle 0 means 2 only, minus J 12, I guess. Yes, 2 minus J 12 is the total current. Why it is 5? No, this is 5, sorry. Calculation mistake. This is 5. Sorry, I completed calculation mistake. 5 minus J 12. It is option C, C for Chennai. Option C it is. So tips for electrical students. I'll tips, tricks, all that I'll give in the last, okay? Yeah, now it is not possible to change the font, man. It is blurry. That's why I'm bringing down at least. Okay. Yeah, this is damn simple question. Okay. So this is the maximum font only. Yes. Understood this question? Like, come on, man. Try to respond at least. Yeah, fine. Let's go to the next question. Okay. So this is direct theory question. Okay. Saying the lowest and highest critical frequencies of RC driving point impedance respectively. What is driving point impedance? You take RC network. Okay, RC network. Okay, this is port 1, this is port 2. This is called as driving point. Means driving point impedance means voltage from one port, current from the same port. So Z11 is called as driving point impedance. Okay, now this is 1 by CS, this is R, this is R. Now if you do it, you will get simply impedance. Yes, you will get one pole and one zero. One pole, one zero. See, the lowest will be 0 and highest will be pole. Lowest will be 0 and highest will be pole critical frequencies. Poles and zeros are system critical frequencies. Number of times I explained to the students who attended previously, right? That is a simple theory question. Leave it off. This question is previous gate question in 2011, I guess. This question is given in electrical paper for 1 mark. Damn simple question. But here the change you can observe here is, here load resistance is not variable. In fact, source resistance is variable. Little down I'll bring this circuit, little down I'll bring this circuit. Okay, do it please. 1 minute is the time I'm giving. Do it. Yeah, this is damn easy question. Okay, see, all questions are easy only. No question is difficult. Okay, now when source see, do remember, when RL is variable, RL should be is equal to RTH. When if RL is variable, if RS is variable, then RS should be as minimum as possible. I repeat, ఎప్పుడైతే సోర్స్ రెసిస్టెన్స్ వేరియబుల్ అవుతుందో, ఇఫ్ సోర్స్ రెసిస్టెన్స్ ఇస్ వేరియబుల్, అది జీరో అయినా ఓకే, మనకి ఇది జీరో అయినా పర్లేదు. ఈ మొత్తం జీరో అయితే టోటల్ వోల్టేజ్ లోడ్కి వచ్చేస్తుంది, హ్యాపీగా మాక్సిమం పవర్ లోడ్కి వెళ్ళిపోతుంది కదా. లోడ్ రెసిస్టెన్స్ కనుక వేరియబుల్ అయితే ఇది కండిషన్. సో ఆర్ ఇన్ ప్యారల్ విత్ 6 ఎంత మినిమం అయితే అంత మేలు. మనకి ఏమవుతుంది, 6R/6+R. ఆప్షన్స్ లో జీరో కూడా ఉంది చూడండి. ఒకవేళ ఆర్ కనుక జీరో అయింది అనుకోండి, జీరో. ఆన్సర్ ఈస్ జీరో. ఆప్షన్ ఇస్ డి. It is not A, Jayasai, it's not A. That's what I'm saying. The concept of maximum power transfer theorem, whenever load resistance is variable, then load resistance must be equal to Thevenin's resistance or equal to source resistance for maximum power to transfer. But whenever source resistance itself is variable, if the source resistance is zero, that is the utmost welcome condition for us. To remember, when source resistance is zero, when source resistance is variable, the source resistance must be as minimum as possible for the maximum power transfer to the load. Now source, in the source place, what is there? R in parallel with 6 is there. R in parallel with 6 can be 0 if R is equal to 0. R is equal to 0. Let me know you guys understood this concept or not. Yes, all of you. All of you, let me know whether you guys understood this one or not. Yes, please. Jaysai, Nishita, Tejas, Gautam. So this is crucial statement. Otherwise, you'll commit mistake. You have, so what you do is, this must be equal to this. This is not variable, na? This is fixed. We derived maximum power transfer theorem by keeping RL as variable. What about equivalent then, sir? Which equivalent you are talking about? See, that equivalent and all, when RL is variable, then RL is equal to RTH, which is equal to R equivalent. When, if RL is variable, but RL is fixed here, RL is fixed here, RS is variable. Okay, I try to apply the concept, not the formula, right? Now, when this is variable, if this is zero for us, total voltage will go to load without any drop here. What is the power? V square by R, 100 by 3, 33.3. Under no circumstances we get more power than this. Even water may be the value of this, or water may be the value of this. That should be zero, right? This question, people waste their valuable time in doing blah, 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 so many things, right? A lot of things they do. But simple question, how, sir? These two are equal resistances, na? 8 amperes is coming here. This is 4 amperes. This is 4 amperes, right? Now, this is 4 amperes means this voltage is how much? 40 volts. This voltage is 8R. Yeah. Voltage is equal to current into resistance. Current is 8, resistance is R. Apply KVL, minus 100 plus 8R plus 40 is equal to 0. So 8R is equal to 60. I guess 100 minus 40 is 60 only. R is equal to 60 by 8. How much it is? 30 by 4, 15 by 2, 7.5 ohms. That's all. Option is B, P for Bombay. Right? Yes. Done. Simple question. Solve this next question, please, all of you. All of you. I'm giving 1 minute of time. Solve it. Yes, 1 minute of time I'm giving. Solve it. Yes, little blur upside. Okay. And the circuit shown figure of the magnitude of VL and VC are twice that of VR. But in fact, indeed, he is saying one thing that VL is equal to VC. Why? Because VL is equal to 2 times of VR. VC is also equal to 2 times of VR. Indirectly, VL is equal to VC means circuit under resonance. Given that F is equal to 2 periods, then the inductance of the coil is asking about L, right? Okay, these two voltages will be exactly equal and they will get cancelled. Now the current is how much? Current is 1 ampere. Now what is that VR? So VR is equal to 5 volts. Now what is VL? VL is equal to 10 volts. VC is also equal to 10 volts. That's fine. What is VL? Omega L into I. Yeah, VL is equal to I into XL. XL is equal to omega L into I is how much? 1. That is equal to how much? How much VL? 10. So omega is 2 pi f. 2 pi f is 50. L is equal to 10. So L is equal to 10 divided by 100 pi. So L is equal to 1 by 10 pi, right? That's all. 1 by 10 pi. So in terms of millihenry, how much you get, that will be the answer, right? Nishita is saying it is option B for Bombay, 31.8. Just I am taking by believing in her calculation. Okay, please, any one of you tell me if the calculation is something other than that. If the calculation part is okay, 31.8. That's all, 31.8. You see, if you observe those who are asking me for tricks and tips, no, if you see questions on theorems, questions on KVL, questions on transients, and questions on this resonance, most of the questions are from these topics only. And definitely, definitely one question will be there from two-port networks. I repeat, definitely one question will be there from two-port networks. Definitely one question will be there from resonance, one question from AC analysis, one question from theorems, one question from DC analysis, like finding equivalent resistances, star delta, from this part. Okay. So that as of now, the tips for the preparation are practice as many problems as possible, but learn concept from those problems, not just mug the problem. If you are not getting that question, you are not clear with respect to that concept. Now get the clarification of that concept and you proceed further. That is only the mantra. Now, as of now, I never suggest you to listen big theory classes, lengthy classes, not required. Lengthy classes are not required as of now. Okay. Yes. Come on, man. So anything you thought of asking, please. I'm waiting. I'm giving you 2 minutes of time so that you ask me more questions. So those. Yes. What is this question? This is also, he's asking for impedance. In a series RLC circuit, L is equal to C is equal to R is equal to the impedance of the circuit at resonant frequency. Is a question, first of all? Read that question, try to answer. Simple question. In present syllabus, they didn't mention two-port network. See, that's the point. That is, see, Genco, Transco, SPDCL, EPDCL, CPDCL are state level exams. Never you trust the syllabus given by them. If a subject is not given, we can ignore it. Subject is not given. But if a topic is not given, don't feel that questions from the topic may not come. We can't say. Why? Because mostly paper is not qualitative most of the times in state exams. Okay, paper is prepared. I don't know, they will prepare the paper by sleeping or by eating or something, but paper is not qualitative most of the times. See, in syllabus they won't mention, but questions will come. Okay, if you ask how you can give questions on this if it is not mentioned in the syllabus, they will link with some other topic. Okay, if that is mentioned, obviously this is mentioned, that way. So that's what I'm saying. The topics which are not mentioned in the syllabus, I repeat, the topics which are not mentioned in the syllabus, you prepare in the last. But surely you prepare if you get the time. If you get time, surely you prepare the topics which are not mentioned in the syllabus, but you prepare in the last. That is smartness. Okay, answer this question. I don't know who given, on what basis that fellow given this question. I don't know. Is a question, first of all? At resonance, inductive reactance and capacitive reactance magnitude wise both are equal. Okay, circuit will be purely resistive. If purely resistive, only resistance is going to left. That's all. Option is B for Bombay. I don't know. Means they are very lazy to prepare good questions. That's why they given this kind of simple questions. I hate really. Okay. Okay. What about 23? Okay. Yeah. This is also no pen paper required for this. If you're little good at signals, little good. I'm not asking you should be very good at signals and systems. If you're little good, simple, this is sine omega t, right? This is sine omega t. To this one, what is added? Plus DC source is added. DC source is added. If you add these two, what you get? This way you're going to get. That's all. Why you get pure sine wave is not possible, not triangular, not ramp. Sinusoidal superimposed on a ramp. It is not on a ramp. Yeah, fine. He's asking about the current. Correct. He only correct. I committed a mistake. It is the voltage. Overall voltage, what we applied. Now, when we do DC, see, when you are giving AC to sinusoidal source, current will be AC. See, Vm sine omega t you are giving as voltage, then current will be by XL. But for DC plus, this is sinusoidal. For DC, what is the current? V is equal to L di by dt. IL is equal to 1 by L integral V dt. V is DC. So V by L into T. Yeah. What is integration of a constant? It is multiplied with T. Now plus V by L into T. Now this is a ramp. This is sinusoidal. A sinusoidal superimposed on a ramp. This is a voltage source actually. Yes. This is the input voltage. This is input voltage. But this is the output current. Option is D for Delhi. Perfect question. Option is D. Yaar, who is B? Previous question B, yeah, you told? This is D for Delhi. Observe it once. Very good question. I thought about voltage source. Voltage source is this one only. But current is, as you are giving sinusoidal, current will be sinusoidal. But when you are giving DC to an inductance, IL is equal to 1 by L integral V. V is equal to L di by dt. L di by dt. Now V by L, from this V by L di by dt, integrate dt is equal to I. The same thing. V by L into T. Integration of a constant is ramp. Please draw that, sir. Which one? Why to draw? What you will do? V by L into T. Why to draw this one, man? This already drawn. No? Why to draw this one? Arre, come on, man. See, your questions are ridiculous actually. Why to draw that? I'll repeat the solution once. See, Vm sin omega t istunamma. As it is two sources it is having, we can apply superposition. One source I am taking. I am considering sinusoidal source first. Then for sinusoidal, it is XL. This is the current because of sinusoidal source. Now, current because of ramp, VL is equal to, for an inductor, DIL by dt. Now, VL is VDC is equal to L DIL by dt. Now, from this one, DIL by dt is equal to VDC by L. So, IL is equal to, VDC is constant, L is constant. Integrate on both sides for one time with respect to T. You get it as VDC by L into T you get. This is ramp. Y is equal to MX is the ramp. Why to draw that? Okay. So total current is Vm sin omega t by XL. This is sinusoidal. Whatever it is sinusoidal. Plus some ramp. What is that? VDC by L into T. As you asked to draw, I'll draw it, which is not necessary at all. But still, I'll do that for you. Right? Rough diagram I'm drawing. This is ramp. Sinusoidal superimposed on ramp. Will be maybe this way. Right? Just I'm not concentrating on the values and all. Okay? Right? Do this question. Damn easy question. If you're not doing this question, I'll really feel bad. Damn easy question. Do it. Answer please. What is there in this? Some people are giving 0. In steady state, I think it's not 0. In steady state, what will be the capacitor voltage? C2, if C1 and C2 both are same. In steady state, both the capacitors will behave as open circuit. Okay. Now, draw the diagram. That is better for you. Draw the diagram. Here there is resistance. Okay. Now, this is plus minus V. Now, this capacitance C1 is equal to C. This C2 is also equal to C. If two elements are having equal value, voltage will be divided equally. Voltage will be divided equally. So this is, let's assume it as Vx. That this also will be Vx. Now no current in this one, 0 amperes. Why? Why no current in that? This is open circuit. Here also open circuit. No closed path for the flow of current. Write the KVL. Minus V plus Vx plus Vx is equal to 0. 2Vx is equal to V. So Vx is equal to V by 2. That's all. Nishita, committed mistake. Huh? Option is A. None of you, in fact, none of you. Come on, you want me to explain this one once again? See, both the capacitors will act as open circuit. Open circuit means current is 0. Voltage may be some value. We don't know. Open circuit means current will be 0. We are unable to comment on the voltage unless we calculate. In short circuit, voltage is 0. But voltage, we are unable to comment on it. Sorry, voltage is 0 in short circuit. Current, we are unable to comment unless we calculate it. So this is Vx, I assume. This is also Vx. Why? Why both are Vx? Why? Because both the capacitors are same. Why current through this one is 0? Current is 0. Why the current through that is 0? Because there is no path for the closed path for the flow of current, right? Yes, it is V by 2. Why it is 0? Why it is V? But there is something fishy here. That is, if this current is 0, this voltage is 0, right? That voltage is 0. If this voltage is 0, these two are parallel. This will bring down to this one to 0. Right, correct. It is V. It is V. It is not V by 2. It is V. Yes, it is V. Good, good. Nishita, good. It is V, ma. It is V. But you tell me whether you did with the same concept or not. Okay, this initial way of discussion is this. Okay, but it should be Vx by 2. This is V by 2. It should be if this resistance is not there. But because of this resistance, as the current through the resistance is 0, as the current through the resistance is 0, this is 0 volt. These two are parallel. If this is 0, this also should be 0, right? Then total voltage should appear here. Whether you've gone with the same concept or different concept. Yeah, that is in steady state only. See, steady state capacitor behaves as open circuit. See, steady state, I'll repeat, steady state capacitor behaves as open circuit. Yes. But there is a resistance here. There is a resistance here. First of all, no closed path for the flow of current. No current can come from here. Why? No closed path here. Why? Because this is under steady state. Now this is 0 amperes. Why? From source only current should come. If current is leaving, there is no return path. Therefore, this current is 0. If this current is 0, this is 0 volt. This should be also 0 volt. If this is 0, that is virtually treated as short circuit, right? Now, this is Vx, we assume. Now, Vx is equal to, good question it is, good question. Previous gate question it is, right? Yes or not? Yes. I did not solve this question previously. If I would have solved, I won't commit this mistake, nah? Right? Try this. Oh, this font is very small, it seems. Huh? What will be the rise in the capacitor voltage per second? Is asking rise in the voltage. Come on, man. A voltage source in series with current source. Good question. Voltage source in series with current source. Now, some good points to understand. He's asking dV by dt. dV by dt. Do it, please, all of you. 1 minute of time I'm giving. Do it. Yes, answer for this question, please. Arey yaar, simple question. IC is how much? 2 amperes, irrespective of this voltage source. If current source is there, that current is main for us. Okay. IC is equal to C is how much? 2 microfarads. dV by dt, dVc of t by dt. You want this value, that's all. So dVc of t by dt is equal to 2 gone, 10 to the power of 6 volts per second, 10 to the power of 6 volts per second. You know, you are interested in this value, but I am interested its understanding. You know, if that way you design the circuit at a rate of 10 to the power of 6 volts per 1 second, means if you switch it on for 1 second, the voltage that is going to appear across that capacitor is 10 to the power of 6 volts. How much dangerous it is, you think of once. Okay, anyhow, it is not the I can say conventional gate class or something to understand concepts in depth, which are not required. Now you concentrate mostly on the competitive examination, not on the concept, depth concept. Okay, its practical applications and all not required for us as of now. Okay, this question: what will be the average power drawn from the voltage source? Very good question. Okay, good question and simple question. In fact, good question and simple question. Try it, please, all of you. Try it. Good morning, Nishita. Previous question. It is D. Yes. See, very simple. See, this current is I. What is the power in that? I square R. Nothing to do with this source. As I told you, if there is a voltage source in series with current source, forget about voltage source. That is nothing to do. Means this circuit is happily equivalent to this circuit. Equivalent, I'm writing, not exactly equal. This is I, this is R. And more precisely, if you want to understand, this current is coming. Now this is plus minus. This current is entering here. Maybe it may be absorbing the power, but it is not supplying. That's why it is zero. That's why it is zero. Good question, man. Good question. Area under the sine or cos over a single cycle is zero. Come on, man. Then voltage will be zero. Average voltage will be zero. But how come power is zero? The statement, Nishita, what you wrote there is not suitable over here, because area under the sine, yes, it is well known fact that area under one full cycle of sine is zero. Therefore, V average is equal to zero, or I average is equal to zero. But IRMS and VRMS still exists, which are not equal to zero, and power is because of RMS component, not because of average component. Okay, Nishita, your answer is correct, but the approach is wrong. Your statement is absolutely wrong. Means your statement is correct, but not suitable here for this question. Okay. This is a very good question and simple question. Today, someone in the WhatsApp group asked me about this question. I solved and sent. I solved and sent this question. Okay. If you want, I'll write it in bigger font. Okay, I'll write this one in bigger font. Okay, he's saying R1, R2 both are equal. This is R3, this is R1, this is R2, both are equal. This is plus minus 5 volts. This is plus minus V volts. That fellow is saying, what he's saying is, he want this one current to be 0. Anyhow, we take this one as reference. This is 0 volt. Now this is also 0 volt. Why? Because here the voltage drop is 0. Now if it is 0, directly I can apply Ohm's law. This current is 5 by R. Now no current is flowing this way. That 5 by R, according to KCL, the same current should flow here, 5 by R. Okay, right? 5 by R1. This is also 5 by R1. Anyhow, R1 is equal to R2 is equal to R. Let's take as R1 equal to R2 equal to R. Right? Now, what is asking? What voltage magnitude? Let me write the KVL for this. Let me write the KVL for this. Minus 5 plus 5 by R1, right? Or let me write this way. Let me write this way. What is this current? 5 minus 0 by R1 is the current from here. That is equal to, here this voltage is 0. 0 minus V by R2, which is equal to R1, which is equal to R, both will get cancelled. 5 minus 0 is equal to 0 minus V. Minus V is equal to 5. V is equal to minus 5 volts. V is equal to how much? Minus 5 volts. Observe it once. Take 1 minute of time and observe it. Got this question, all of you? I think all of you got this question, right? Right. Go for the next question. This is also very easy question. What he's saying is, I'm reading the statement for you as it is not clearly visible. A series RL circuit is excited at t is equal to 0 by closing the switch as shown in the figure. Assuming 0 initial condition, the value of d square I by dt square at t is equal to 0 plus will be. He's asking for d square I by dt square. First, let's get the di by dt. Minus v. Why minus v? This is plus minus, and switch is closed at t is equal to 0. Right? Minus v plus R into I of t plus L di of t by dt is equal to 0. Right? Now, as the switch is closed at t is equal to 0, the current is 0. See, all this we are doing at t is equal to 0. At 0 minus, the current is 0 minus, current is 0. At 0 plus also, at 0 plus also, current is 0. Right? Minus v plus L di of t by dt is equal to 0. L di of t by dt is equal to v. Okay, assuming 0 initial condition at t is equal to 0 plus he is asking. So a series RL circuit is excited at t is equal to 0 by closing the switch as shown in figure. Okay, switch is closed at t is equal to 0. Assuming 0 initial condition, initial current is 0. Okay, that is also fine. d square I by dt square. It is 0. It is 0. Now, what do we get? di of t by dt is equal to v by L. Now, derivative it on both sides for one more time. d square I of t by dt square is equal to 0. Answer is 0. 0. Why? Because initial current is 0. Initial current is 0. As this is a constant, anyhow, we got I of t is equal to 0. Okay, I of t is equal to 0. Why? Because he's asking everything at t is equal to 0 plus. At t is equal to 0 plus, IL of 0 plus is equal to IL of 0 minus is equal to IL of 0. He is saying this switch itself is closed at t is equal to 0. Before the closing the switch, the current is 0. Right? Answer is 0. 0. Try this question, please, all of you. Yes, this is determine the current through the capacitor during steady state. During steady state, capacitor is open circuit, current is 0 amperes. This is a question, first of all? I really hate this kind of simple questions. Okay, so we are going to end up this session now. As I told you, always start with network analysis. This is a strategy: network analysis, then control systems, then means first or parallelly you can start networks, parallel with the machine, control system parallel with power system. But these subjects are very important. Most of the people will prepare these subjects in very depth, but they ignore these subjects, which they are going, due to that, they are going to lose the marks, right? Network analysis, control system, actually these are the scoring subjects. Anyhow, machines and power systems, all electrical engineers will study in depth. All electrical engineers definitely will study in depth, right? So we are starting module, question practice module, yes, from 1st of July, that is from tomorrow. Those who are interested in the module, please, you can call me, okay, for all further details. This is my contact number that is mentioned on the board, right? If you have any queries, you can call me directly, right? All the best. Thank you.